Good evening, everyone. Welcome to the class of cyber.
Good evening, sir.
Yeah, good evening. So actually, while we are waiting for others to join, actually I have already forwarded an email to everyone, uh, the same Google form, right? So some of you already started to fill up. So just I request while others are joining, just take a time of 2-3 minutes to fill up that form and submit your selected cyber physical system, right? So that we can utilize that time while others are joining. So I hope everyone is in position to receive the email. Just spare the 2 minutes to fill up the form. Then actually we can start the session. So I hope everyone has received the Google form and start to
Yes, sir.
fill up.
Received.
Yeah. So just actually we are going to wait for another 3-4 minutes.
Fill the form, sir. Already done.
Yes, you have actually entered the data. I think uh, already Meena, Harshit, Satyendra, all you have actually entered the data that I am able to see. You also selected your partner. The Sunil Gupta is going to be the partner of Satyendra, while Meena is having a project partner. I think she has selected four partner: Mobin, Sajid, and Rajnikant. All are actually working in a group. Okay, so I think now 4 to 5 and 4 2 and 1. So almost 7 8 kind of entry we can consider that we have received. So moving forward, actually, as we have started to discuss about the capturing the data related to uh, capturing the data related to temperature and humidity into the last session. We also see in the demonstration. I hope everyone has received the stuffs what you might have ordered through the channel, which means the e-commerce channel, and then I hope that everyone has tried to implement the things that we'll discuss later on. If you already implemented the stuff and finding any kind of difficulties. So next Sunday also we'll have a demonstration, but on a slightly advanced version kind of thing. Into the last session we have discussed that how to acquire the data to our own computer through serial monitor, and we had a hands-on session on that. So today also will not go into the very much technicality of the content, but will also go through the system through which actually now will go through the process of login through the open source tool which help us into the data streaming to the cloud and through the Android application. So just I will go through the demonstration of it today, and then meanwhile into the, if someone has not already say, received the stuffs what we are trying to achieve, what we have ordered, right, and then we'll have a demonstration how to stream the data to the cloud to Android, and how the data will be used into the monitoring purpose. So basically last time here at this point actually we have stopped. It means we were able to collect the data through the serial monitor in terms of temperature and humidity through the sensor of DHT11, and then we will be going to expand our knowledge from our own serial monitor captured data or says data stored into the our own desktop or PC to the streaming of the data to the cloud through the Wi-Fi module, and then from Wi-Fi module to the online open source cloud to Android. So then actually the DHT11 entire cycle will be over. The similar thing we are going to implement for the K type of thermocouple into the next session, into the Sunday session, into the hands-on session, so that many of you have actually opted the project related to monitoring the temperature of furnace or so. So then actually it can be easily understood how to capture the data from the melting furnace or heating furnace in the range of slightly onto the range of say 1200 or 1300 degrees centigrade. Right. So basically that's what we did, manufacturing system, and then we are going to identify the typical our own physical system. So now actually we are having a lots of option available for the sensor, as you might have selected your own cyber physical system. So based on to the parameter uh, you have opted out. For example, if you are going to measure out the power consumption, but actually there is no sensor available to capture the power consumption. So you need to disintegrate your thought into the uh, basic available sensor. For example, power, then power will be disintegrated by the either voltage or current, and then you are going to integrate with that sensor, and along with the timer. So whenever we are having a say voltage, current, and a timer, then we'll be in position to understand how the power consumption will happen. So basically the sensor will give you idea about voltage, current, or maybe it is possible through the time. But into the programming side, you need to do the certain kind of computation. The same way, suppose someone has already selected the project related to say before cup, in which we are going to measure the say viscosity or flow of the liquid. So in which actually we are going to utilize the time from which the flow has been started, or we are going to capture the moment where the flow stops. So in between that actually we are going to compute through the program, and we'll be able to find out the difference of time. So why actually I ask you to thought about the parameter, because as our intention is to find out something, and we need to also look it into the types of sensors available with us, then actually we will proceed somehow that the sensor of the result will be further processed and it will give us the desired results. So manufacturing system to the parameters, then we are having a certain types of sensors available. For example, if we are interested to find out the say stress, right? But actually there is a sensor which is difficult to find out to have a direct value of stress. So finally, we are going to provide some kind of input related to area, and we will measure the force with the help of either Lord cell or any other mechanism, right? So suppose our intention is to find out the strain, then actually original length we are going to measure by something, then we are going to adopt the strain gauge. By that actually we will able to find out the change of length and similar kind of thing. So if you are going to talk about the strength or as a strength stress value, we don't have a sensor for that. So you need to disintegrate the strength. It means say either force divided by area. So finally we will measure the force. But at the same time, suppose you will go into the domain of say civil engineering, where there are say flexural strength, modulus of rupture, and all we are going to measure. But even on that place, we don't have a say. Sometimes it may possible that we don't have a provision of load cell. Then actually it is going to be rely through the proving ring system, where actually the displacement, linear displacement will be converted into the circular displacement kind of with the help of dial indicator, and each division of the dial indicator will be related to the value of force. So there are certain kind of processing is required onto the sensor data, and how will you do that? So for that actually you need to have a provision of different microcontroller board. So as I told you, our life becomes very easy by the evolution of the microcontroller board. Earlier, there were no provision of the microcontroller board, ready-made board like this. So at that time, the people who are expert into the embedded systems were used to develop a kind of controller. Through the controller, then all the library need to be installed, all the library need to be prepared with the help of programming language associated with the C, C++ and all. And but as soon as say Arduino kind of boards were evolved, actually that made our life very easy. So nowadays actually you don't need to have a separate microprocessor. All the chips are readily available into the microcontroller board, and all the processing can be done. So whether you want to connect it with the Wi-Fi, whether you want to connect with the Ethernet, whether you want to connect through the Bluetooth, Zigbee, any kind of, even the infrared, all kinds of things are readily available. So we are having a multiple choice of microcontroller board. So out of these sensors, this sensor DHT11 we have taken, and out of this microcontroller board, last time we have discussed the application of ESP32. But there are so many such boards are available. So that actually makes our life in a sense more complex, that which microcontroller board is very much suitable for my application, and even the which sensor I should use. So always the sensors are having their own data sheet available while you are actually purchasing the sensor. You need to understand the sensors data sheet and their function very well. For example, the voltage ratings are mentioned into the sensors data sheet or their library or their uh, description. So you need to go through that, how much amount of voltage is required. Basically it does require how much amount of current and at what frequency the data will be captured and what range of data can be captured, right? Suppose there are certain sensors which are actually only dealing into the analog system, right? For example, some sensors are based onto the voltage, some sensors are based onto the current. It means finally all the sensors are working in a physical fundamental that it is going to capture the some physical quantity, and they are supposed to convert 99% of the sensors, they are converting the physical information into the either voltage or a current. So the sensors which are having a rating in terms of voltage are very easy to embed with the microcontroller board, and it is very easy to what you can say, write a program about it, or it is very easy to have overall control. But some of the sensors which are actually transforming the physical quantity into the current, like say RTD sensors, which is also kind of sensors in which we are measuring the temperature along with the thermocouples and all. So there are certain RTD sensors which are actually transforming the physical quantity into the current. So for that it becomes very difficult to embed with the microcontroller, right? Because it requires a certain kind of specification. You need to have a certain kind of library available, because anyway, see, we are going to be the end user for the sensors as well as microcontroller. We are not going to develop our own library. So first utmost requirement is to check whether the sensors library are available for a particular microcontroller board is there or not. For example, if you are going to use the DHT11 with ESP32, so easily library is available. It means the sensors library is available DHT11 for the ESP32. But it may possible, say for example, if you are going with the very high pressure sensor which is dealing into the more than 150 bar pressure or so, which are used in many of our manufacturing system, like if you are dealing into the die casting, high pressure die casting machine where our pressure range is very high, same way into the wax injection pressure, the pressure range is very high, same way into the any other application like say plastic extrusion machines where the pressure range is very high. So at that time actually we are having a pressure onto the high range. So this kind of microcontroller like say ESP32 or many of the Arduino boards are not compatible. So for that either you will have to go with the Raspberry Pi or Jetson or some of the board related to Intel. And as some of you are already dealing into the machine learning and image processing, so at that time also, suppose sometime you are dealing into the manufacturing, sometimes you are dealing into the image processing, then few of the image processing libraries are not available to have an interface with the microcontroller board. So if you are going to develop a certain equipment or device where the image processing will play a very important role, then suppose you are going to do the image processing with the Python Keras library, then it is not compatible. It means it cannot, this kind of data set will not be handled by ESP32 or Arduino, or sometimes the few version of the Raspberry Pis are also not compatible with that, because it does not provide that kind of computational effort. So this is all how actually the selection of the microcontroller is happen, and the sensor selection is also depends on that. So while you are selecting the sensor, you should keep the things into the mind that which kind of microcontroller board you are going to use. And there are certain peripheral requirements. As we know that the sensors are always and the microcontroller board always are dealing in terms of very low voltage, as well as you can say into the DC power supply. And commonly we are having either say single phase AC power supply or three phase AC power supply as far as our industrial power supply is concerned. So essentially it becomes very critical to transform that alternate current or say AC power supply into the DC power supply, and then you are having a better connectivity in terms of cable with the power supply. But overall, whatever your connections are happen between your microcontroller and sensors and peripheral requirements like say SMPS and all, there has to be requirement of the PCB, right? That is a printed circuit boards, in which we are just going to print the circuit. So finally the connection is likely to happen onto that, and for that actually the special skills are required to design the PCB and even the printing of the PCB. But as we know that we are not actually into the electronics class, but these all peripheral things is required to be understood while you are dealing into the development of your own cyber physical system or say cyber manufacturing system. So sensor is one part where the physics is involved, microcontroller where the electronics will play a very important role, while into the designing of the PCB and printing of the PCB, selection of the most appropriate power supply source, all play a very important role. And this is all about our course. After once we'll finish the demonstration, we'll also go into some more details onto the sensors, microcontroller board, as well as this peripheral requirements. And once you are actually connecting all these things together, then we will be in position to capture some kind of information. That's what we have discussed at the end of the previous hands-on session, that we will be in position to capture the data. So the major challenge actually, while it is not the challenge when you are actually dealing with the only one parameter, but it is becoming more complex while you are dealing the multiple parameters, multiple sensors, multiple microcontroller boards at a time, because still we have not thought of the frequency of the data collection. Suppose I will just share the very small example. If you are having a say collection of the temperature from 5 different locations, right? So the frequency of the data collection will play a very important role. If I'm going to collect the data of the per second, right? So per minute I will be having a 60 temperature data and multiply by more 60. So per hour I will be having that much amount of data. And if I'm going to consider the 24 hours, still 60 multiply by 60 multiply by 24. And if I'm going to multiply it by the 30 days in a month, so 30 multiply by 24 multiply by 60 multiply by 60. So that is the only one parameter, one temperature that we are collecting at the frequency of 1 second. So while you are actually developing the cyber manufacturing system, you should be very much sure about the frequency, because finally at only one temperature will require tons of storage space if you are considering, right? And if you are considering say working of your company 24/7, then obviously 365 days, 24 hours, 60 minutes, 60 seconds, you are collecting the temperature. So you need to be think in that direction whether this frequency is required or not. Say for example 1 second frequency is required or not. So depends on to that. And if you are collecting similarly say 120 parameters, so again this will be multiplied by the 120 information. So all this will become a huge information to deal, and that is related to say process parameters. So then actually you need to decide that which kind of server you are going to utilize. Either you are going to procure your own server, or you are going to stream all the data to the cloud. Still, I will try to increase the more complexity. That, for example, in my company, I'm going to utilize the 4G, or say I can say 4G speed of internet, right? But I'm going to share the data to the cloud. For example, any cloud provider you can take, either it is a Amazon Web Services or GoDaddy or any other that you think of, right? So for example, I'm collecting the data at 1 second. So see the complexity, how it will actually play a very important role, and at that place how the typical cyber physical system and its complexity comes into the picture. So every second, suppose I'm collecting the temperature, so sensor will collect the temperature. Finally, it is going to be processed by the microcontroller or any kind of processor, and then it will send it, or it will be sent to the cloud. And then actually from the cloud, again, you are going to utilize that data for the monitoring purpose. For example, in my cell phone, I want to monitor the temperature of a particular cyber physical system. So every second, actually, the data is going to capture, streaming to the cloud, again cloud to the my mobile. So in that place, connectivity between your microcontroller to the cloud. Suppose you are using the 4G internet, and then from the cloud, it is going to having some refreshing rate, right? Because it is not going to happen that immediately you are going to stream the data and the data will be updated onto the cloud. So there will be some kind of time delay happens, or time lagging will happen. And that time lagging will be starting from the few microsecond to minute. It means in terms of minutes, right? It may be 2 minutes, it may be 5 minutes, it may be up to 6 minutes, right? Or many more, right? So depends on to the data that you are going to capture per second. It is going to stream to the cloud. Then there will be a refreshing of the server happens. Once the refreshing of the server happens, your data will be updated and will be able to, or we will be able to visualize the data onto our cloud, our cell phone or my dashboard. So generally what actually we are feeling, if we are going to use the 3G kind of internet speed, and on an average cloud server, that delay is as much as 2 seconds, right? So actually whatever the temperature I'm going to see into my device, that I will be able to see into my mobile after 2 seconds, right? So then it becomes very important as far as the controlling of the equipment is concerned through the smart device. So suppose same kind of time will happen once I will control the device from my mobile to the machine. So same if I will have a monitoring 2 seconds and again sending back the command. So again it will have say nearly 1.5 second, 2 second delay. So that will become nearly 3 to 4 seconds of delay, right? While you are actually operating the machine through smart device. And for that actually the speed of the internet and the server what you are going to use will play a very important role. So as far as our say development is concerned, we can easily say that, okay, we are going to use the cloud. But into the cloud also, you need to search properly that which kind of server, which kind of cloud that you are going to use. So if you are going to search about AWS or any other system which are actually providing the cloud-based service to you, they are also mentioning the refreshing rate of the server. So you need to see that at which second or how many seconds the data is going to be refreshed. So in our purpose, actually, we are going to acquire the data. Right now, we are not going to deal with that much amount of complexity as we are into this learning phase. So first we will understand how to capture the data and streaming to the cloud or say our own server. Once this data is going to be acquired, right? as I told you, we are going to see that onto the real-time monitoring system, right? And we'll convert that information in terms of chart or status, whether it is on or off, right? And then actually we are going to, once the data is stored actually, then first we are going to utilize this data for the most common application, which is prediction of the quality, prediction purpose, or say forecasting purpose. And if the forecasting is done properly, then we'll go with the data analytics kind of system. Then we are going to analyze the data for future purpose, right? So this is the overall scenario. We have actually reached up to this stage for the temperature purpose only. Then into the next Sunday, we will understand how to represent this data onto the cloud-based application, Android or dashboard. Then slowly by slowly, we'll repeat the same kind of concept for other 2 or 3 type of sensors. And once we will be having a sufficient data, or you may also having a sufficient data, we'll run that data for the prediction purpose. And once the prediction is done, we'll going to discuss about the data analytics part. So prediction we are going to do with the help of statistical approach, as well as artificial neural network based approach, where we are going to utilize the data for training and testing purpose. And then into the data analytics, we will be trying to find out why it is happening, right? So here actually the first part will give you idea about what is going to happen, and the next part will give us idea about the why it is going to happen. So this is the overall thing, right? And then actually again we'll capture this information, and again this information will be going back to the original physical system, that whether the prediction is going to happen, so you want to change the cycle parameter or not. And if you are having a list of parameters which are affecting the performance of the system, then again you are going to feed this data to the system again, right? And then entire cyber physical system is considered to be developed, right? So now our next time, I just quickly go through the kind of demonstration thing, that into the next time what we are supposed to do into the Sunday class. So now we have seen that into the earlier demonstration that we have installed the DHT11 library, we have captured the information and stored into our whole server. But now our job is to transfer the data through the Wi-Fi module. It means through the Wi-Fi connection or Wi-Fi internet, we are going to transfer the data to the server or say cloud, and from that actually we'll see into the form of charts or other form that you would like to have. So for that actually just a little bit extension what you are supposed to do with the Arduino. Just you need to go into the Google and search out Wi-Fi H library import, Wi-Fi H download, and you will see the certain GitHub things available for that, and that you are going to click. You will again, it will direct you to the GitHub, where you will find the code that you are going to download in the form of zip, and again you are going to install it to your own Arduino stuff, right? So now one more thing that we are supposed to do onto the today's session itself, so that will help us in going through the demonstration of the Sunday. So now everyone need to kind of creating the account into the ThingSpeak. So those who are having an account, well and good. Those who are not having an account, please, you are supposed to do right now. Just as soon as I will finish the things into the 2-3 minutes, just go into the Google, type ThingSpeak. So whatever the first IoT analytics, ThingSpeak, Internet of Things will come into the first thing that you are supposed to click on the first one. then it will lead to this kind of dashboard. Here you are supposed to click the get started for free, although it is also available on a commercial aspect, but then the speed of the server, as I told you, will be different. But as we are actually dealing for our own simple purpose, so there is no point of having this kind of thing. So once you click that get started for free, it will ask you the email. If you already registered, or if you are already having an account with MathWorks or MATLAB, well and good. If you are not having account, then just press the create one, right? And then you will find that you need to enter the email address, location, your first name, last name, and press the button continue. Right? So once you will press the button continue, it will register your email into the MATLAB. Then they are going to send you the one verification email to the email address what you have entered. So again, you need to go to your own email service provider and go with the verification of email. Once you will verify it, it will ask you to enter the password for your particular ID. And once you will enter the password, which is more or less most probably 8 letters, one capital, one numbers, one small, everything. So if you are going to fulfill that kind of condition, and then it will ask you to continue with that, then it will lead to this kind of questions. So you can select, I would suggest you to select last two options, any one of them, teaching or research in school or student use, and tell us something about your project. You can say that development of the cyber physical system for particular course or something. Then once you will press the button OK, it will take you to this kind of dashboard. So now actually up to this we will be doing now, right? So I'm just waiting for that. I think it will not take more than 2-3 minutes to do. So I would suggest you to start the process on that. Right? So start that thing. Then it will take you to this channel.
Commercial work student use, sir.
Sorry, your voice is not coming. Yeah.
Should I use it as use option commercial work or student use?
Yeah, whatever you can write, no problem in that, right? But I would suggest you to go with the last two options. They will actually provide a good idea about the student version, and it's a very good tool to use it. Right? So once you will go that new channel, we will supposed to select. And for the new channel, actually, now the main advantage of this system is that we can easily create the application programming interface with the help of ThingSpeak. It means there is no need to generate the separate API, right? Now I hope that everyone is aware about what is API and all. API is nothing but whenever you are dealing into the two different kind of platform. For example, the sensors are collecting the data. There is a separate protocols. There are separate programming language for that. And once you want to transfer that data to the another platform or another programming language, so for that actually to creating the interface between the two different applications which are having a different programming fundamentals altogether. So at that time you need to have a API, right? So API is nothing but it is a typically it is a one-line statement through which actually you will communicate with between the two different two applications which are having a two different programming fundamentals. For example, if you want to transfer the data from a database which is based onto the SQL to the say Android, if you want to call the certain kind of data from SQL to Android, then you need to have a API. Same way, if you want to transfer the data which are collected from sensors to the database, which is based on to the SQL. So for that, actually, you need to have a API, right? So here, this ThingSpeak is actually providing a good information in that they are actually generating the API for us so that we can easily utilize. But again, it is only that you can utilize for the educational purpose. But suppose you are developing your own application or your own tool, then you will all have to learn how to create the API. I will also show you that typical API which help us in transferring the data from Arduino to PHP, PHP to SQL database, and SQL to Android. I will also show you that how the API were generated, right? So now actually you can, if possible, now you can log in through the ThingSpeak. And I will also
Done, sir.
go through. Done. Very good. So once you will once you will reach up to this dashboard where you are having a visualization in terms of my channel, you can just press the button New Channel. It will allow you to generate a new channel. You can give away any kind of name. Suppose I have given humidity and chamber description. Suppose I will tell that, okay, I'm supposed to do the certain kind of thing. Whatever you can write down, it is not a mandatory field. But in a one channel, as many as 8 parameters you can capture. So I'm just trying to capture the humidity and temperature. I just need to put this. And then I will, without going into the too much of trouble, I will directly go into the press the button called Save Channel. So now actually it will allow us to save the channel, and here you will be able to see that API keys. So this API key actually, which is very much important as far as our temperature and humidity transferred to this ThingSpeak is concerned, right? So here you need to save this API. API will be different for each individual login. So that API we will generate and we'll save it. It means copy that API and we will save it at some location, right? And that API will be further utilized into the Arduino programming, right? Because we are supposed to transfer the data from Arduino to ThingSpeak, and where this API will play a very important role. You should also remember the channel ID, right? And suppose author, whatever you are actually mentioning, it will be given to you. So channel ID will be generated and API key will be generated. You can also select how the data will be visualized, right? In terms of two channels, say humidity and temperature both. So here you can see that how the charts will be generated. You can also see that at widgets, you can also change how the data will be look like, whether it is going to be utilized as a numerical values or gauge or lamp indicator, whatever you want to see. So numerical indicator can be used like this, how the data will be utilized. Same way you can also select as a different forms of data, like say gauge. If you want to see the temperature in terms of gauge, you can also see that, and charts are also available. So no problem in that, right? Then actually into the again, sorry to trouble you again, but you need to go to your on Play Store. Google Play Store. I assume that everyone is using Android phone, but the same application is also available onto the Apple Store. Right, so just you need to go through that, and just you need to type ThingView, right? And you will be in position to find out the one application that you are supposed to install in your respective cell phone. So again, the name is ThingView. Earlier one was ThingSpeak. Now it is ThingView, right? So once you will go there, the similar application is also available onto the iOS, right? So whether you are using the Apple device or Android device, you will be in position to install it. So just you need to install it. Once you will install and open it, right, it will showing the first page like this. It will show that you don't have any channel for that. So here actually you can add the channel. So once you will press the button plus or say addition of the channel, it will take you to the add all my channels, and then here you need to provide your URL and the API key, right? So from here actually you can take this API key that you are supposed to enter over here, which is also available here, right? So there are two different kinds of API you are dealing. Here this API that we are actually earlier storing, and this API will be utilized into the Arduino, right? So as I told you, from sensor to this database, different API will be required like this, which starts with the R, and another API that you require, which actually streams the data from this server of the ThingSpeak to my Android. So there will be a requirement of different API. So here you will see that the different API will be required. So once you will go into the my account, my profile, and here there will be a user API key which starts with the V, right? So that you are supposed to enter over here. So then it will connect the Android to the ThingSpeak. The earlier API was used to connect the Arduino with ThingSpeak. So now the entire channel has been created from the Arduino to ThingSpeak to ThingView, right? So once you will enter that, it will show that whatever the channels you have stored, and you are supposed to save it, right? And then it will go to that, right? So any confusion up to this part, anything, and then actually we will understand how to import the code into the Arduino for connecting the DHT11 with Wi-Fi, right? So that is over here. We are supposed to utilize this API key over here. As you have seen that we have included the Wi-Fi library, and as you have seen that the string key which is available starts with the R. So this API key is mandatory, right? This API key is mandatory to take it from the ThingSpeak. So suppose you don't want to use the ThingSpeak, you want to use your own server, your own system, then here the API, you need to generate the API and paste it over here. So that actually the data will be start to stream from Arduino to a particular server. Then you need to write down this, your Wi-Fi configuration. Here just simply I have pasted SSID as a 123, which is your Wi-Fi username. So this inverted comma thing you need to replace by your own Wi-Fi username. Suppose you are going to utilize the your own it means hotspot of the particular hotspot of the cell phone, then you are supposed to use this one, right? That particular ID, then the password, and this is the common api.thingspeak.com, which is our server where actually we are going to stream the data. So in place of the different server, we are supposed to use the IP address of that particular server, right? So actually now I'm going to stop at this point, right? And as the further section will require basically just about how to get the Wi-Fi code and run it into the our Arduino, right? Then you are supposed to run the Arduino from that. As we are not dealing into the typical programming, so I will just I will hand over the code to you so that you can just fill up that code and do the necessary modification. You can also go through the code through the any kind of search engine, which is nothing really new into it, which are already available. And once you will finish that code, the data will be streaming to the ThingSpeak like this. We have also utilized a few of the widgets so that the numerical values are also possible to stream. Same way kind of gauge are also possible. This is the dashboard version of ThingSpeak, and the similar version is also available onto the ThingView application where you can easily stream the data and visualize it, right? Like this. So this is the code for the demonstration what we had earlier for the serial monitoring for the last Sunday what we have discussed. This is the code what we have utilized with the help of DHT11 and everything, right? Just you need to paste this code into the Arduino board, connect the DHT11, ESP32 and your laptop. But you need to be very much careful which kind of port that you are going to use. You need to modify that port into your Arduino tool. Right? And this is the code what we are going to use for our next week demonstration. Say for the Wi-Fi connectivity between DHT11 to ThingSpeak to ThingView. The flow of the code is like this. We are going to write down the code like this and then this one, right? So here the API key will be different for the individual user. Here the SSID will be different. Here the password will be different for an individual person, right? Because you are going to have your own API key generated for your own purpose, right? But most of the remaining things will remain as it is. We are not going to change any kind of code, right? So these two codes actually we are going to utilize specifically this code we are going to utilize into the next demonstration, and this code we have already utilized into the last demonstration. So I hope you will go through this video and start to do the practice onto the DHT11 with ESP32 if you have not received it. And then again, with the help of minor modification, if you are having your own physical system, minor modification will happen in this code. Same way in this code, to have your own thermocouple or timer or maybe anything, right? So minor modification will happen in this. So I hope you will get what I am trying to convey, and into the next Sunday we'll have a demonstration onto the same. We are going to connect the DHT11 with Wi-Fi and stream the data to the ThingSpeak and ThingView. And we will also see, if time permits, that we'll also see how to connect the K-type thermocouple and stream the data to the server. So we'll understand the DHT11 and K-type thermocouple separately. Then we will combine all the data and see how the codes are going to change and how the things will work out. right? So I think that's it from the my side, at least for the today's session. Wishing everyone a very happy Gudi Padwa and happy New Year, especially for our part. Right? So if you are having any doubt, any concern, please feel free to ask. And I hope say everyone has, yeah, I think Prem Singh, Abhishek, Meena, Satyendra, I think all have entered the data into the form what I have shared. Still, I think many of you are missing. Oh, I think the Prem Prakash Singh has entered too many things, right? Parameter associated with that. So selected physical system is disamatic. Okay. And send block pressure. It means it is kind of machine what you are using, right? Into the casting.
High pressure molding machines, sir. It's a high pressure molding machines used for
This is making that.
prints and molding, sir.
Hmm. Okay, so I think that's it from the my side for at least for this session. Again, we'll meet on to the Sunday, right? Okay, thank you everyone for sparing the time and having patience in listening.
Thank you, sir.
Thank you. Yeah,
Thank you,
thank you
sir.
everyone.
Thank you,
Thank you.
sir.
Bye bye.
Thank you, sir.